Do not expand the bottom. Do not even think about it. That's too much work. We do not want to see you expanding. We do not want to see you doing any of that. This is the form that we like it, and just keep it. Just knock it off. Don't do that. Everybody, welcome to Cranky Calculus. We're here to find the derivatives of inverse trig functions. Do not forget to like and subscribe. So the first thing we're going to see here is we're going to look at all the different derivatives of inverse trig functions. So like arc sine. By the way, please take note that arc sine of x is the same thing as sine to the negative 1 of x. Just notationally, that's all it is. But all these derivatives, if you notice, the sine and the cosines are pretty much the same thing, except for the cosines can produce a negative value of that derivative. Tangent and cotangent are the same thing, except cotangent is going to produce the negative of that. Secant and cosecant are the same thing, except cosecant is going to produce the negative of the secant. And you can find this out by using implicit differentiation, which we do have down here. So feel free to pause that video and kind of look to see what the heck is going on here. But that is the proof of what is going on. So what we're going to do here now is differentiate each of these and just kind of be aware that all of the arc trig stuff does involve chain rule, unless it's just the base form. So for the first one, for differentiate, we're going to get dy dx is equal to 1 over the derivative of the arc sine is going to be 1 minus square root of 1 over, I'll say it right eventually, 1 over square root of 1 minus x squared. In this case, our x is 3x plus 2, and that's all being squared, times the derivative of the inside of this function right there. Derivative of 3x plus 2 is just 3. So I can rewrite this nicely as 3 over, do not expand the bottom. Do not even think about it. That's too much work. We do not want to see you expanding. We do not want to see you doing any of that. This is the form that we like it, and just keep it. Just knock it off. Don't do that. All right, that's actually our final answer right there. Next one is I kind of go over to this inverse tangent, which is being cubed on the outside. So we got some chain rule here. We got quite a few chain rule. Ooh, this is going to be a doozy. So I'm going to first do the 3 arc tangent of root x squared. That's the derivative of the outside. Now I'm going to do the derivative of the inside here, which is 1 over, arctan is going to be 1 over 1 plus x squared. So it's 1 over 1 plus, in this case, our x is root x squared, times derivative of root x. Hopefully you have that memorized. Root x derivative is 1 over 2 root x. Have that memorized. Okay. Very minor cleaning up here. It's just going to look ugly, but that's okay. You don't need to do too much cleaning up here. The only cleaning up I'm going to do here is I'm going to actually put this 3 arc tangent squared on top in my numerator. Okay. All over, I'm going to put this 2 root x out in front here, times 1 plus root x squared is actually going to equal absolute value of x. Which I guess the absolute value of x is a little bit redundant, since we do have the square root of x. Square root of x only produces positive numbers, so our domain of this anyway is from 0 to infinity. So yeah, anyway, this is going to be our derivative. That's as simplified as I can get. I don't want to simplify any more than that, and I'm not going to. Okay, right here we do have a little bit of product rule, so let's go ahead and do this. So I'm going to get, let's do a different color. Let's go ahead and get dy dx equals product rule. Derivative of the first is going to be just 1, so it's going to be arc cosine plus x arc cosine is negative 1 over square root of 1 minus x squared. Really, there's not cleaning up to do here. I'm just going to just make this look prettier. Minus x over square root of 1 minus x squared. Okay, and that's all that is. I do want to take a quick little note here, is that if you ever do have, I probably need to zoom out more. Oh boy. Can we even see it on the bottom? Oh, there, you can see it now on the screen. At the bottom there, note that the inverse tan is not the same thing as tangent to the negative 1. Just take note of that. That's good to know as you're doing some problems. Anyway, moving on here to our last one. We do have an arc secant problem. So let's go with one more color here. I have not done purple yet, have I? I have not done purple. So I'm going to get dy dx equals, so we have a chain and a chain and a chain. Okay, so the first one is going to be the arc secant, and then we're going to have an e, and then we have the 4x. So for the arc secant, it's 1 over absolute value of x, which is e to the 4x, square root of x squared minus 1, so this is going to be e to the 4x squared minus 1, times the derivative of e to the 4x, which is, that's a baby chain. Hopefully you know what the derivative of e to the 4x is, just 4e to the 4x. Okay, now if I rewrite this a little bit more, this one does clean up just a bit, and I would just worry about the cleanup part just because of its multiple choice. I'm sure it'll be cleaned up. This is going to be 4e to the 4x all over the absolute value of x. Means that we're going to be positive. This is already positive. So the absolute value is redundant because e to the 4x can only be positive. So let's rewrite this as e to the 4x. And this is e to the 8x minus 1. Last thing here, these e to the 4x's will cancel out, and I will get a final answer here of 4 over square root of e to the 8x minus 1. And that is going to wrap up our video here. Do not forget to like and subscribe.